Wait, they shattered a planet? How does that even happen? How do you shatter a planet? One of the most intriguing additions in Factorio Space Age is the shattered planet. That's quite an extreme thing to happen to a whole planet, and as you're flying through the debris field, it's quite clear that the whole planet really has been broken apart. This isn't a situation where only a bit of the planet has been broken off. The whole thing is in bits, and it's become an asteroid field. Before we get going, it's going to be a bit confusing calling it shattered planet all the time, especially when I'm talking about it pre-shattering, so I'm going to christen it Bob. Also, since the asteroids are mostly materials that we'd find on a planet like Earth, we'll get to Prometheum later, we'll assume Bob was an Earth-like planet in its size and composition. But what would it take to shatter a whole planet? Well, it depends how big the planet was, but for an Earth-like planet, it requires around 2.5 times 10 to the power of 32 joules of energy. Yes, that's a number with more than 30 zeros in it. A whole ton of TNT only releases about 4.2 times 10 to the 9 joules of energy. The megatons that's used for nuclear weapons means the explosive energy of 1 million tons of TNT. So that's 4.2 times 10 to the 15 joules of energy. To get the energy in megatons, we can just divide one by the other. That gives about 6 times 10 to the 16 megatons. The biggest nuke that we've ever detonated on Earth was the Tsar bomber, which was about 50 megatons. That means it would take around 10 to the 15 Tsar bombers. Yep, that's pretty big. There are some more exotic approaches, which I'll talk about later, but you can reach those sorts of energies in a couple of obvious ways. You either use something that's very big, or you go very fast. Very fast here means an appreciable fraction of the speed of light. Okay, so this is going to get a bit physicsy and a bit mathsy, so I'll present it in a way that I think anyone can follow. In classical, or Newtonian mechanics, the kinetic energy of an object is governed by the equation Ke equals a half mv squared. Kinetic energy, which is shown by the Ke, is simply the energy associated with something moving. Therefore, what this equation is showing is that kinetic energy is proportional to mass, represented by the letter m, which is to say that the heavier something is, the more energy it has when it's moving. I've worked up a very simple example here to show this. We have a 5 kilogram mass travelling at 5 meters per second that has a kinetic energy of 62.5 joules. If we double the mass to 10 kilograms, the energy doubles as well to 125 joules. An object that's twice as heavy will have twice the kinetic energy if it's travelling at the same speed as another object. But the kinetic energy is also proportional to the square of speed, which is shown here using v for velocity, which is just a fancy term for speed. I've worked up another example to show this, where our 5 kilogram mass is now travelling at 10 meters per second, so a doubling of the speed, but the energy goes up to 250 joules. What that means is that if we double the speed, it actually quadruples the energy. This is why something like an asteroid, which could be relatively small compared to a planet, can still do a devastating amount of damage if it's moving very fast. Okay, so that's the basics. Let's use this to look at how a natural disaster, such as Bob being hit by another stellar body, might have caused him to shatter. An asteroid or meteor impact. The answer to getting that much energy that you may instantly have thought of is an asteroid or a comet impact. After all, one of those did for the dinosaurs, right? Well, that's one of the theories, but notice how there's still a planet Earth under your feet. Earth has been hit by quite a few of these big asteroids in its life. Indeed, if we look at many of the other planetary bodies in our solar system, we see that they're absolutely covered in impact craters. Rocky moons like ours have loads of the things, yet they're still there. Such impacts are relatively common. Space is so big and so empty that rogue rocks can be floating around and not hit anything for billions of years. And if you have a big gas giant in a system, such as our Jupiter or Saturn, then their gravity can cause stuff to be thrown around, meaning the problem basically never goes away. But our problem is that whole energy thing again. The energy an asteroid or comet impact is likely to produce would probably not be at the scale we need. Because a planetary system is orbiting around a star, that puts some upper limits on object speed. Put simply, if something is going too fast, then it can escape the star's gravitational pull and disappear off into the void. That is, if they're going faster than the escape velocity, then they'll escape. I mean, it could be more complex than that. This asteroid could have had several gravitational slingshots that mean it's going fast enough to escape, but then Bob gets in the way. So let's do the maths based on that idea. Let's assume it was an asteroid 3 times the size of the one that killed the dinosaurs. Now, we don't actually know how big the one that killed the dinosaurs was, but estimates range from 1 times 10 to the 15 kilograms to 4.6 times 10 to the 17 kilograms. So let's assume it was 3 times 10 to the 16 kilograms, somewhere in between. Let's also assume that it's going at a relative speed of 3 times the escape velocity at Earth. We'll make the simplifying assumption that it's a neutral collision. By this, I mean that the angles don't really come into play. It's head-on, so we get a nice big speed and the maths is not too complex. One thing to note here is that Bob is actually quite a long way out compared to the other planets. That means that anything out there would actually have a lower escape velocity. But let's imagine that the asteroid came from the inner system. The escape velocity at Earth is 42 kilometers per second. We can convert that into meters per second by multiplying by 1,000. So that gives us a speed of 126 kilometers per second. For reference, estimates for the dinosaur killer are around 15 kilometers per second, so we're considerably faster than that. This also gives us an upper and lower bound for a realistic estimate for the dinosaur killer, as shown here. Plugging that into our formula gives an energy of 2.4 times 10 to the 26 joules. 26 may sound close to 32, but that's powers of 10. So we are a considerable way away from our required energy of 2.5 times 10 to the 32 joules. Or, to put it another way, we need to hit Bob with 1 million asteroids that were 3 times the size and going 10 times the speed as the one that did for the dinosaurs. Even if we say we're not trying to atomize Bob, I think you can see that a natural asteroid or comet impact isn't going to do the trick. But, as I've noted, size is a key factor in the energy maths, so perhaps something bigger than an asteroid could maybe do the trick. A planetary impact. But what's bigger than an asteroid? Could something on the scale of a planet do the job? Well, first off, you have to bear in mind that the dividing line between a planet and an asteroid is a little arbitrary. Pluto, for example, has been reclassified as a dwarf planet. This is because it's more like a really big asteroid that has a more spherical planet-like shape. So in other words, you're basically just saying bigger and bigger space rock. You may be thinking here that the problem is more about how something as big as a planet would have taken so long to impact another planet. Wouldn't a planet-sized object have hit Bob way before now? Well, you may have heard of something called Theia. This is a theory that the Earth was hit by another protoplanet, Theia, during its formation. The theory is that this is where our moon came from. The impact smashed 2 similarly sized but smaller planets together and left behind the Earth-Moon system. So there are possibilities, but if this did happen to Earth, then it happened within the first few 100 million years and way before life emerged. Such big-scale collisions and the time needed to form things like oceans mean that life can only really emerge once all of that big stuff has calmed down a bit. Nauvis and Gleba have complex life, and Fulgora is old enough for a whole advanced technological civilization to have grown up and died out. That means this isn't a newly formed system. There aren't big rogue objects wandering around smashing into each other like in the early planetary formation stage. So am I saying it couldn't have been something as big as a planet? Well, maybe it could. Another strong possibility is a rogue planet. As I mentioned before, objects that get a big gravitational slingshot could exceed their star's escape velocity. This can happen when you have a large gas giant and it flings them off into the void, becoming what's known as a rogue planet. But space is really big and really empty. It's therefore quite a small chance that a rogue planet would wander into the reach of another star. And then it's an even smaller chance that it would go on to crash into another planet. But galaxies have a lot of stars in them, and the likely number of planets is enormous. So this probably does happen on occasion. Okay, what does a planet-sized object do to our maths? Well, we come back to that how big is a planet question. I've already mentioned Pluto, so let's use that planet as our reference. Pluto weighs around 1.3 times 10 to the 22 kilograms. If we plug that in, we get 1 times 10 to the 31 joules, so we're very close. Let's look at the 126 kilometers per second case. If we go up to that speed, then we get to 1 times 10 to the 32 joules. So we're extremely close. What if the planet was bigger? Well, the Earth weighs 6 times 10 to the 24 kilograms. If we plug that in with the lower speed, then we get 5.3 times 10 to the 33 joules. So we're there, right? I also looked today Super-Earth, which is an exoplanet that's around 10 times the size of Earth and going at our higher speed of 126 kilometers per second. That would give an energy of 4.8 times 10 to the 35 joules. So in other words, Bob being hit with a similarly sized planet would give us enough energy to break him apart fully. But there's a lot of assumptions there. How big Bob is, how big our rogue planet is, how fast the relative velocity is, and even the extreme unlikeliness of a rogue planet hitting Bob in the first place. Speaking of unlikely, a black hole. I already mentioned that there were some other possibilities, and one of these is that Bob could have encountered a black hole. An encounter with a black hole would certainly be enough to rip a planet apart. But notice I said rip apart. The immense gravity around a black hole could set up tidal forces in Bob that tore him to pieces. This is obviously assuming Bob was far enough away to avoid getting sucked in altogether. But my problem here is, why doesn't it also break up the other planets? The planets in the Nova system are actually very close together, yet none of them seem to have been affected by this theoretical black hole at all. And even if everything aligned perfectly to mean Bob was shattered and everything else was fine, where is this black hole now? If we entertain this possibility further, then I guess it could have happened long enough ago that the black hole wandered off. But this therefore begs a related question. Why aren't the other planets dead? In space age, the whole Nauvis system is drowning in asteroids, but all of the other planets are basically fine. It's difficult to understand how the surfaces of the planets haven't been devastated. We also see that it's only the smaller bits of Bob that have moved into the inner planetary system. All the big stuff is still quite close to where Bob was presumably orbiting. Isn't that a bit weird? It's almost like the shattering was controlled somehow to keep all the bigger pieces in place. But how could that be? Unless it wasn't natural. Let's take a look at Bob's icon. What is this showing? Well, obviously it's showing a planet being shattered. Sorry Bob, it all sounds quite painful. But notice how it's showing it. The planet is kinda exploding. If a planet had been shattered by the impacts that we've been talking about, or by encountering a black hole, then would it look like that? I don't think it would. Firstly, if it was an impact, then surely they'd show that. And if it had been ripped apart by gravity, it wouldn't have looked like it had been detonated by a bomb. A bomb in the middle. It really does look like that, doesn't it? So maybe it wasn't a natural disaster. And so, we turn to the engineer's role in all this. Could it be that Bob wasn't destroyed by a natural disaster? Was he instead destroyed by something unnatural? What might that look like? Well, first off, it could still have been an impact. I mentioned before that kinetic energy is proportional to mass, but also proportional to the square of speed. And what was limiting our speed before was things like escape velocities and space being so empty. But if we're talking about some artificial object hitting Bob, then our reasoning can change. Perhaps it could have been a thrown or pushed asteroid. In that scenario, how fast would the asteroid need to be travelling in order to deliver the right sort of energy? Insert record scratch sound effect. That, for some reason, people still know what it means, even though vinyl records haven't been a thing since the 1980s. Okay, admission time. In the first version of this video, I messed up, because the point I was trying to make was about ramping up the speed. And, when you get very fast, meaning appreciable fractions of the speed of light, you need to account for relativistic effects. That changes the kinetic energy calculations, but I didn't do that. As such, I've edited the offending parts of this video out. To be honest, it was a bit too detailed anyway, so you're not really missing much, but I've left the old version of the video up for members as a little bonus since it was a member that pointed out the error. Instead of remaking the whole section, I'm just going to quickly present the big numbers. If you were to use a Bob killer asteroid, then you would need to accelerate it to about 1,000 times our previous max speed. This would deliver the required amount of energy. Note that it was actually basically the same without the relativistic correction, because we're talking about such huge amounts of energy. That speed takes us up to about 40% of the speed of light. To put that in context, the space probe Voyager travelled at around 1,000 kilometres per second. Of course, Voyager was trying to study the planets, so it was moving relatively slowly, and so maybe it's not a good comparison point. The speed of light is around 300,000 kilometres per second, so that speed is approaching half the speed of light, to the extent that I think it's probably unfeasible to get a normal asteroid up to those sorts of speeds. Okay, so how about something artificial that's been accelerated to an even greater proportion of the speed of light? The point I then went on to make was that an artificial object, like a block of tungsten, is equally impractical. Let's say it was something like tungsten. This has a density of around 20,000 kilograms per meters cubed. The Titanic had a volume of around 130,000 cubic meters. Therefore, if you use the same speed of 40% of the speed of light, then that still ends up being a block that's equivalent in volume to more than 1,000,000 Titanics. Even if you ramp up the speed to something like 99% of the speed of light and use the densest metal on Earth, osmium, then you still need a block that's the size of more than 150,000 Titanics. The problem here is a fundamental one. The energy I gave is the binding energy for the whole planet. It's the energy you'd need to break the whole planet into its component atoms, and we're not actually looking to achieve that. There aren't really any masses given in the game, but a huge asteroid is clearly an okay size for the engineer to deal with, so I think we can knock several orders of magnitude off of our energy target. That still puts us beyond the natural disaster territory. Remember that the original dinosaur killer was around 10 to the 23 joules. Let's instead say that we need to get to 2.5 times 10 to the 29 joules in order to break Bob into reasonably sized chunks. If we use both this new, lower energy target and use 99% of the speed of light again, it's still more than 150 Titanics, which I don't think is a practical approach, but we're getting much closer to the right sort of ballpark. Now back to the rest of the original video. And if it's a deliberate action, then you could imagine an approach that uses smaller projectiles to steadily break the planet apart. We don't mine resources on Earth using one big explosion. We use smaller explosions and slowly chip away at the problem. Incidentally, the US military did deploy atomic demolition munitions, or ADMs, in the Cold War. These are essentially nuclear landmines, and the possibility of using nukes in civilian mining operations was also explored by the USSR. It sounds like we're missing a Hollywood movie somewhere. Anyway, I think anyone looking to mine out a planetary core would do similar. Steadily break it up into pieces until it got small enough to handle. But I'm getting ahead of myself a little. I'm going to do a whole separate video about why the engineer was in the system and what they were doing. But for the purposes of this video, I'd like to mention two distinct possibilities. An accident. First off, I do want to note that this wasn't necessarily a deliberate thing. Instead, it could have been an accident. We know that the engineer crashed on Nalvis, so perhaps they accidentally hit Bob first. But in that case, wouldn't the engineer's ship have been completely destroyed? Well, yes, but I'm thinking here about an interstellar ship. What hit Bob could have been a ship capable of supporting a lot of the engineer's people, not the small ship that crashes on Nalvis. Think about that one bit in that one Star Wars film. And perhaps the engineer managed to get away on an escape vessel just before the impact with Bob. This smaller vessel could then have hit a bit of Bob, a bobbit if you will, and then crashed on Nalvis. My problem with this is I come back to the graphic of Bob getting shattered. Sorry to keep dwelling on it, Bob. It really looks like it's been exploded, doesn't it? I guess it could have been a giant interstellar ship hitting it, but I'm not sure the graphic fits with an impact at all. Well, not a normal impact anyway. Knowledge from God. I think it's worth cutting to the chase and speculating about what I think happened to Bob. First off, I think promethium is the big clue. Unlike all the other materials in the game, promethium isn't a real-life thing. We know there's a lot of abstraction in Factorio, but everything except promethium is based on real-life stuff. Iron, copper, oil, holmium, calcite, it's all real-world materials, even if it's used in a lot of fantastical ways. Promethium isn't. In Greek mythology, Prometheus was a titan who stole fire, essentially knowledge, from the gods and gave it to mankind. The parallel to how promethium is used in the game is fairly clear. Promethium science is the science that's used to improve the yield from other sciences. It's like pure knowledge. Prometheus was punished for his crime. He was tied to a boulder, and each day eagles would peck out and eat his liver. His liver would then regrow overnight so that it could be eaten again the next day. The reason it's the liver is that the Greeks believed that this was where emotions resided. So it's a bit like being condemned to have your core self brutally eaten away from within every day. Lovely. But this also kind of works for Prometheum in the game. It's the core, or liver, of the planet, and we're the eagles returning over and over to eat the chunks. I'll speculate more on this in the dedicated video that I mentioned. Subscribe for that nonsense. But maybe this is what the whole planet shattering was about. That's why we're here. The engineer species travelled to the Nauvis system to harvest the Prometheum from Bob. Sorry, Bob. And to do this, they shattered the planet to get at its juicy livery bits. And that's why the icon looks like it does, and why all the Prometheum is still relatively close together. It's been deliberately broken up to make it easier to harvest. And, as I established in my video exploring what the engineer is, we know that we're an absolute monster. So going around breaking up planets to get at their livers is in keeping with this. Okay, let's assume the engineer's culture did do it deliberately, trying to get at the Prometheum. What might a deliberate attack actually look like? A planet buster. One possibility I've mentioned is to fire something at the planet at incredibly high speed. As I've shown, as you approach the speed of light, even smaller objects have a huge amount of energy. By the way, this is actually how particle accelerators work. Speeding atoms up to an appreciable fraction of the speed of light and crashing them together releases an enormous amount of energy. Energy that then, and my physics viewers will have to forgive my phrasing, condenses into exotic particles that we've not seen before. Anyway, we already know that the engineer's culture is comfortable with railgun technology. And yes, if you've read a certain novel series, then you know the type of thing I'm getting at with all this. I can imagine them using such a weapon to steadily shatter the planet in a controlled way. This would enable them to keep most of it, and in particular the Prometheum, roughly in the same orbit. The debris, the small, medium and large asteroids, are just rubbish to the engineer's culture, and they don't really care that they drift off into the main system. This possibility therefore does align with why the whole system is so full of debris. It does make me wonder why the engineer would get hit though. I guess this could have been their first time doing it, but surely you'd know to keep your distance. Sounds like speculation for another day. Either way, another possibility I want to explore is very high power explosions, but delivered in a very specific way. As we've been discussing, the energy required to smash apart a planet is huge, even if you're only trying to break it into bits. On top of this, smashing things onto the surface is pretty inefficient. Let's look at how they use explosives when mining on Earth. The approach is to dig into the material, bury the explosives inside, and then detonate them. This transfers the maximum amount of energy into the thing you're trying to break apart. So I think to break Bob apart using an artificial explosion, you would need to put the explosives inside the planet. Surface explosions are going to waste a lot of energy, since much of the blast would be reflected back out into space. Instead, I think you'd need to tunnel the explosives deep into the planet so that all of its energy went into breaking the planet apart. I don't think you'd need to necessarily go as deep as the core, but it would depend how deep what you're trying to get at is. Otherwise, you'll be looking at stripping the outer layers away, like peeling an onion. That's a possible approach, but it really depends what you're trying to do and what capability you have. What we do know is that Bob is completely broken up, and I'm guessing that's because the Prometheum is deep in Bob's core, and that's what the engineer's culture was after. As we've established already, I don't actually think any normal fusion or fission type explosion will be powerful enough to break a planet apart, not unless they were taken to ludicrous scales anyway. And then you get into the question of practicality and viability. Why make a giant fusion bomb and tunnel it deep into a planet when you can just use smaller bombs to throw asteroids, or a whole load of asteroids, at the planet? Now if you've got the technology, a more viable solution is an antimatter bomb. A matter-antimatter explosion produces way more energy even than a fusion bomb. This is because it converts all of the mass into energy, compared to only a fraction of the mass for a fusion explosion. Of course, antimatter is very difficult to produce and probably impossible to find naturally. But if we assume the engineer's culture has moved beyond things like capitalism, or maybe never had it, and is producing these bombs for reasons, then why not? I guess in this option, if you're just making it without regard for the costs, You could use surface delivery and not worry about the wasted energy. But if you can make that amount of antimatter, then delivering it subsurface is probably not much more of a challenge. Another interesting possibility here is that perhaps it could have been combined with the high-speed projectile idea. So, they fire a bomb at the planet at very high speed, and this is what takes it deep into the core where it then explodes. I think this is viable in the sense that it could work, but I do come back to the costs of this compared to the other options. And I don't really mean financial costs. Making such a thing is complex, and it's both time and resource intensive when compared to just throwing things at Bob. So why do it? This video is long enough already, so that's what I want to talk about in the why video. Is that enough unsubtle plugs for you to subscribe yet? Okay. How about all three? I think that the most likely option is that they used a combination. If they were available, they pushed some asteroids at Bob. Then, while these were on their way, they set about manufacturing the antimatter for the Planet Busters. The Planet Busters could then be fired by Planetary class railguns into the holes created by the asteroids. Their deep core explosions would then properly break up Bob. The giant pieces that would result could be broken into more manageable chunks using super dense, non-explosive railgun slugs fired from the same Planetary class railguns. Once that whole process was complete, the engineer's culture would then set about breaking those bits down further using smaller railguns and rockets. This is what we're able to do in the game. Some other options. To finish off, I do want to mention some more exotic options. For example, using gravity could still be a possibility. They could perhaps have created a gravity well using a short-lived singularity or even a stable black hole, and this could have ripped Bob apart. However, doing this would require a mastery of space-time that we don't really see in the game. I guess there is my whole concept about the engineer species having pocket dimensions that I mentioned in the other video, and perhaps that means black holes are within their control as well? Another option that builds on this area of speculation is that they could have used a wormhole. Perhaps they opened one that goes from the sun into the centre of Bob. This would then dump a whole load of high-energy plasma into the planet's core, which would definitely break it apart. The problem with wormholes, of course, is that they're only really theoretical, and even if they do exist, then they're tiny. Making a large, stable wormhole and anchoring both ends would be quite the technical feat. I did also mention in my video exploring what the engineer is that they might be able to do some sort of teleportation. This would seem to give a much easier route to put a bomb inside of Bob, but it does get into the realms of fantasy. Heck, if I'm going for options like that, why not have nanomachines split the planet apart? Or maybe some big robot that they built that can just reach out and split the planet in two, Galactus style. Anyway, the real problem with a lot of these options is of course that throwing asteroids around is just so much easier. Why go to all that effort when you can just chuck a big space rock at Bob? I could go on, but I think we've been poking at Bob's corpse for long enough now. We need to talk about the reasons they were doing it. But that's for another video, one that you'll be able to get early access to if you're a channel member.